All right, let's get started. This is Math 2. Mr. Trutna here. We're from Clovis High School. We're going to go over Unit 10, Worksheet 1, numbers 1 through 22. Here is Unit 10. Here is Worksheet 1. Okay? And for the first three problems, numbers 1, 2, and 3, what we're going to be doing is we're going to be using the equations and the graphs from our notes. So these are the graphs from our notes. Right here, you will notice in number 1, the equation is y is equal to x to the second power plus 3. You notice in our notes, number 1, y equals to x to the second power plus 3. We already did quite a bit of the work here, and we already have our graph, okay? So we look at our graph right here. Is this a minimum or a maximum? All right, well, here's my vertex. If my vertex is the lowest point, it is a minimum. Okay, what is the vertex? Well, the vertex is the lowest point. Whenever we express a vertex, we always express a vertex as an ordered pair. What is the ordered pair for that vertex? It is 0, 3. Okay, what is the domain of this graph? Well, remember, the domain is how far a graph goes left and how far a graph goes to the right. Okay, so does this graph continuously go as it goes? Does it continuously move out to the left? Yes, it does. Does it continuously move out to the right? Yes, it does. So what's the domain? My domain is negative infinity to positive infinity. Okay, and some people would say that, what does that mean? Well, it's every number. So some people would say the answer is all real numbers. It's every single number. Now, how about the range? Well, remember, the range compares how far does a graph go down to how far does a graph go up. So I look at this graph right here, this parabola. Does it go down forever? The answer is no. It stops going down right there. What number does it stop going down at? 3. So my range is from positive 3 to how far does it go up? Well, these arrows signify that it keeps going up continuously. It never stops. So what number do we use if it never stops going up? Positive infinity. So my range would be 3 to infinity. Some people would say the range would be your y greater than or equal to 3. So it's any number greater than or equal to 3. Okay, number 2, we're using the equation y equals 3x to the second power. And if you're referring to your notes, and my notes are right here, we already graphed number 2. Okay, and this is what the parabola looked like for number 2. Okay, so is the vertex, where my finger is that a minimum or a maximum? It's a minimum. Why is it a minimum? If the vertex is the lowest point, it's a minimum. Where is the vertex? Well, the vertex is at the point 0, 0. Okay, what about the domain? How far does this parabola extend to the left? It extends forever. How far does it extend to the right? It keeps extending. So my domain is negative infinity to positive infinity. And remember, that means it covers all numbers. So some people would say the domain is just simply all real numbers. Okay, how about the range? The range is how far the parabola goes up and down. So how far does it go down? Well, it stops going down right there. So it stops going down at 0 to how far does it go up? Well, it keeps going up continuously. So we say that it keeps going up to infinity. Okay, some people would express the range as y is greater than or equal to 0. All right, number 3 here. So here's my graph for number 3. Y is equal to negative 2x to the second power minus 1. We already worked this problem out and graphed it in our notes, so you're referring to our notes. And there's the graph, there's the parabola for number 3. So is that a minimum or a maximum? Well, it's a maximum. If the vertex is the highest point, it's a maximum. Okay, where is the vertex? Well, the vertex is that point right there. It's at the coordinates 0, negative 1. Okay, now what about the domain? Does this graph continuously move to the left? Does it get wider to the left? Yes, it does. Does it get wider to the right? Yes, it does. So my domain is negative infinity to positive infinity. And once again, you could write that as all real numbers. Okay, how about the range? How far does this graph go down? Well, you can see the arrows signify that it goes down continuously, forever. So it goes forever to negative infinity because it's going down. 2, how far does it go up? Well, you can see it stops going up right there at negative 1. Okay, so how would you represent this? Some people would represent this as y is less than or equal to negative 1. That means anything from negative 1 or lower would be a number that would cover my range. Okay, all right, so now we get down to numbers 4 through 12, and we're going to fill out the table by looking at the equations, and we're going to not graph them. Okay, so what's my equation? So first one, a min or a max. So as you notice in number 4, this is going to be a min. Why do I know it's a min? Well, if I look at my equation here, I notice that my a value is 1/2, and if your a value is a positive value, that means that you're going to get a parabola that's going to go up. Okay, so we know my parabola in this graph is going to look like that, which means your vertex is going to be the lowest point. And your b value here is going to be 0. Now we're going to use the a and the b value to find my vertex. So to find my vertex, I use the formula x is equal to negative b times 2a. b is 0, so I'm going to get 0 divided by 2 times 1/2, and that's going to be equal to 0. So my x value of my vertex is 0. To find my y value, I substitute 0 into my equation. So I get 1/2 times 0 to the second power minus 1 is what y is, and that's equal to minus 1. So my vertex is going to be the point 0, minus 1. Okay, so what's my domain? Well, as we discussed in class, every single parabola, what's your domain? The domain is always negative infinity to positive infinity, or you can express that as all real numbers. Okay, and then what's your range? Well, if you notice, my range always coincides with my y value of my vertex. Okay, so my range would be, since my parabola is a minimum, that's the smallest number that my range is going to get to. So my range is going to be negative 1, and then my parabola is going to continuously go up, so it's going to go up to infinity. Okay, range you represent by your y-axis because we're measuring how far it goes up and down. So how would I represent this as an inequality? Y is greater than or equal to negative 1. Okay, moving on to number 5, we notice that my a value is 4. It is positive, so that means I'm going to have a minimum. Okay, why do I know it's going to be a minimum? Because anytime your a value is positive, that means you're going to get a parabola that is going up continuously. Okay, and then my b value here is going to be 0. So I'm going to use those values, and I'm going to use the equation to find the vertex. So my vertex is going to be negative b, which would be 0, divided by 2 times a, which is 4. 0 divided by 2 times 4 is 0. So my vertex's x-coordinate is 0. Okay, to find my y-coordinate, I'm going to plug my x value into my equation. So I'm going to get 4 times 0 to the second power plus 3. Well, that's equal to 3. So my vertex is at the point 0, 3. Well, what's my domain going to be? The domain is always negative infinity to positive infinity for all parabolas, whether they're going up or down. Okay, we can express that as all real numbers. All right, and then my range, this number tells me my range. If it's a minimum, the y value of your vertex is your first number. And then we know that the parabola is going up, so it's going to be 3 to infinity. How do I write that using just the letter y? I say y is greater than or equal to 3. All right, number 6. So we have y equals negative 3x squared. So if you notice in number 6, your a value is going to be negative 3. So since your a value is negative, that means your parabola is going to be a continuous down parabola, like that. So is your vertex a min or a max? Well, it's going to be a max because it's going to be the highest point. so my vertex is going to be a max. My b value of my quadratic equation is going to be 0. I'm going to use a and b to find my vertex's x coordinates. So my x coordinate is going to be negative b, which is going to be 0, divided by 2 times a, which is going to be divided by 2 times negative 3. That's equal to 0. To find my y value, I'm going to substitute 0 into my equation. I get negative 3 times 0 squared. Well, that's equal to 0. So my vertex is the point 0, 0. We always express the vertex as an ordered pair. Okay, so what's my domain going to be? Well, my domain is always for a parabola, negative infinity to positive infinity. Okay, and we write that as all real numbers. Now, my range is going to be, remember, the y value of your vertex tells you your min or your max. It's a max. So my range is negative infinity to, and then it maxes out at 0. Okay, so how do I write that with just the letter y? This means that y is going to be any number 0 or smaller. So I write my range as y is less than or equal to 0. Last one, number 7, y is equal to negative 1/4 x squared. Okay, so I know that my a value for my quadratic equation is negative 1/4. It's negative, so that means my parabola is going to be continuously going down. So what does that give me, a min or a max? It gives me a max. Okay, then I also know that my b value is 0. So I'm going to use my a and my b value to find my vertex. So my x value of my vertex is going to be negative b, which is 0, divided by 2 times a, which would be divided by 2 times negative 1/4. That is equal to 0. Anytime the numerator of a fraction is 0, it makes the entire equation 0 when you evaluate. Now I'm going to substitute 0 into my equation to find my y value. I'm going to get negative 1/4 times 0 to the second power. That's 0. So my vertex is the point 0, 0. Okay? What's my domain? Domain is always negative infinity to positive infinity for every parabola, which we express as all real numbers. Okay, what's my range going to be? Well, since it's a maximum, my y value of my vertex tells me my maximum value. So my maximum value is going to be 0, and then my minimum value, my parabola keeps going down, so I get negative infinity to 0. Okay, so how do I write that in terms of y? So that means my range is any number at 0 or smaller. So y is less than or equal to 0. Okay? All right, now we answer numbers 8 through 12. So which graph will be the skinniest? So we look at the a value. The biggest a value is 4. Okay, so the bigger the a value, the skinnier the graph is. So y is equal to 4x squared plus 3. That's going to be my skinniest graph. Which graph or graphs will have a maximum? Well, you can see we have them here. Y is equal to negative 3x squared, and y is equal to negative 1/4 x squared. Notice the a values are negative when we have a maximum. Which graphs will have a minimum? Well, it's the first two. It was y is equal to positive 1/2 x squared minus 1, and y is equal to positive 4x squared plus 3. Notice when the a value is positive, we get a minimum. Okay, so which graphs will be shifted up? Okay, well, the graphs that will be shifted up is number 5. Y is equal to 4x squared plus 3. That 3 shifts our graph up. Which graph will be shifted down? Well, it's the one that has a negative or a minus at the end. So y is equal to 1/2 x squared minus 1. Notice that value right there, the minus 1, tells me that my parabola, and when I graph it, will be shifted down. Okay? Going to the back side, we're going to sketch the graph of the quadratic function based on our work from numbers 4 through 7. Okay? So if you notice, number 13 is the same equation to number 4. All right? So what was the vertex of number 4? It was 0, negative 1. So I'm going to go over 0 down to 1. So I'm going to put a point right there for my vertex, okay? Then remember, to make a graph, we just make a really quick, simple table, and my table is going to have 3 values. My middle value is my vertex, 0, -1. And then for my other 2 values, I pick any number for x above x and any number the same distance below x. I'm going to pick +2, which means I have to pick -2. Then what I do is I take that value and I substitute it into my equation to figure out what y equals. So I would get 1/2 times 2 to the second power minus 1. I work that out. 2 to the second power is 4. 1/2 times 4 is 2. 2 times minus 1 is 1. So when x is 2, y is 1, I plot that as a point. X is 2, y is 1. Then, since I know I'm making a parabola, I know on the other side it's the same. So when x is -2, y is 1 as well. So when x is -2, y is 1 as well. And then what I do, to graph it, I just make a nice smooth U, a nice smooth parabola, extend the parabola up just ever so slightly, okay, in order to get my parabola here. Okay, number 14, y equals 4x squared plus 3. I go over here. We notice the vertex was 0, 3. Okay, so I'm going to go over 0, up 3. There's my vertex. All right, now to graph it, what I'm going to do is I'm going to make a table. I'm going to make a simple 3-value table. My middle value is going to be my vertex, which is 0, 3. Then I'm going to pick a point above 0. I'm going to pick 1. Pick the point below 0 the same distance, -1. Then we're going to plug in one of these points, substitute one of these points into the equation to see what y equals. I'm going to substitute in +1. I'm going to get 4 times +1 squared plus 3. 1 squared is 1. 1 times 4 is 4. 4 plus 3 is 7. So when x is 1, y is 7. I plot that point over 1 up to 7. Now, I know when x is -1, since I'm making a parabola, it's the same on both sides, y is 7. So I go over -1, I go up to 7 here. And then I connect the points with a nice smooth U. Okay, and I extend it a little bit past. There's my parabola for number 14. Number 15, y is equal to -3x squared. Where was the vertex? I turn it over here. My vertex was at 0, 0. So I put a point at 0, 0. Then I'm going to make, to graph it, I'm going to make a very simple table. My table is going to have 3 values in it, and my middle value is going to be my vertex 0, 0. So then I pick a value above x. I'm just going to pick 1. I pick a value the same distance below x, -1. Then I'm going to substitute one of these values, not both of them, into the equation to see what y equals. Substituting 1 in, I get -3 times 1 to the second power. I evaluate this. Got to do the exponent first. 1 to the second power is 1. 1 times -3 gives me a y value of -3, which is going to be the same for -1. I plot those points. Over 1, down 3. Over -1, down 3. And then I connect the points with a nice smooth U to make my parabola, extend the parabola past the points. Okay, last one, y is equal to 1/4 x squared. So you could see my vertex was 0, 0. So I put a point at 0, 0. There's my vertex. All right, so then to make my graph, I'm going to make a very simple table, an x and a y table. And I'm going to put 3 values in. My middle value is always my vertex, 0, 0. Okay, then I pick a point above 1 and I pick a point below, above 0 and below 0. I'm going to pick 2 this time, and then I pick -2. Then I'm going to substitute one of those values into my equation to find my value for y. I'm going to substitute in +2. So I would get 1/4 times 2 to the second power. And evaluate this. Do the exponents first. What's 2 to the second power? 4. What's 4 times 1/4? That's equal to 1. So when x is 2, y is 1. That means when x is -2, I get y as 1 as well. I plot those points. Over 2, up 1. Over -2, up 1. And then I connect the points with a nice smooth U to make my parabola. Okay, and my parabola is going to look like that. So you can see that that's my widest parabola. Number 16. All right, number 14 was my skinniest parabola. All right, so we have those right there. All right, you can see in number 14, my graph was shifted 3 spots up. In number 13, you could see my parabola was shifted 1 spot below. Okay, and that's what that -1 and that +3 did. Okay, number 17 through 22, we're going to review factoring. So here we go, x squared plus 30x minus 64. So we know that when we factor this, we're going to get a trinomial, factors into 2 binomials. This is a plus minus trinomial, so I know my factors are going to be plus minus. The first term of each parentheses is x and x, and then I take my last term, 64, and I have to find all the pairs of numbers that multiply to make 64. Okay, so that could be 1 and 64. That could be 2 and 32, and I could stop right there. Because once I get a pair that could be added or subtracted to make my middle term here, my b value, I don't have to find any more pairs. Okay, 32 minus 2 gives me 30. All right, so I know this has to be a positive 32, and I know it has to be a minus 2. Why? Because positive 32 minus 2 is equal to positive 30, which is what I have there. Number 18, I have a trinomial. It's a minus plus trinomial, so I know that when I factor it into it, if it's a minus plus trinomial, I'm going to get a plus and a minus for my factors. No, wrong. I'm going to get a minus and a minus for my factors. Sorry. So let me start over right here. I'm going to get a minus and a minus for my factors. Okay? How do I find them? Well, my first term is x and x, because x times x gives me x squared. Then I take my last term, 24. And now I'm trying to find a pair of numbers that multiply to make 24, but at the same time they have to add or subtract to make 14. I'm done. 2 and 12. I found them. They're both minus. So my factors are x minus 2 and x minus 12. Okay? In number 19, you notice we are missing our middle x term. So one thing we could do in number 19 is we just rewrite this problem as x to the second power plus 0x minus 121. So I turn it into a trinomial. That's the same thing as that. I just wrote it with the 0 here. Okay, so it is a trinomial. Trinomials always become 2 binomials when factored. This is a plus minus trinomial, so my factors are going to be plus and minus. Okay, and then I have an x and an x. Now I need to find 2 numbers that multiply together to make 121, but at the same time they have to add or subtract together to make 0. Well, it's 11 and 11. One of them's plus, one of them's minus. Okay, and if you notice in number 19, I'm starting to see a pattern as I do these. All right, if you notice, the pattern is I have 11 and 11. It's the same number. One of them's plus, one of them's minus. So I use that pattern for number 20 to help me out. Because if I notice, I'm going to get a plus and a minus. Okay, because this is following the same pattern as number 19, where I have a minus symbol and the numbers are perfect squares. So I know what number times itself makes 49. Well, that's going to be a plus 7 and a minus 7. And then how about 36? Well, that's going to be a 6, and I have to put an x, and that's going to be a 6x. So number 20, if you start seeing the pattern for these special problems, that's how you can do it. Okay, number 21. So in number 21, I have a leading number, but I have a trinomial. So the first thing I do is I cross out the leading number and I multiply it by the last number. And I create a new trinomial. X to the second power plus 11x plus 12 times 2 is 24. and then I factor this trinomial. So it's a plus plus trinomial, so that means my factors are going to be plus and plus. My first terms are going to be x and x. My last term is going to be, I'm going to take the number 24, and I'm going to have to find pairs of numbers that multiply to make 24, but at the same time, the pair has to add to 11 or subtract to get to 11. So 1 and 24 wouldn't work. 2 and 12 would not work. 3 and 8 would work. 3 plus 8 gives me 11. So I know my factors are x plus 3 and x plus 8. Okay, well I'm not done though, because now remember, I multiplied by 2, so now I have to divide both of these numbers by 2. I have to make up for the fact that I made it unbalanced at the beginning by multiplying by 2, so I balance it back out by dividing. Okay, does 2 divide into 3? No. So what happens is, if you cannot divide or reduce, you take the numerator number and you're just going to move it up in front of the x. So my first factor turns into 2x plus 3. Okay, then my second factor divides, so my second factor just simply turns into x plus 4. So 21, there's my factors, 2x plus 3 and x plus 4. The last one, I have 9x squared minus 30x plus 25. So I have this leading number here. I'm going to take it. I'm going to get rid of it at the beginning, and I'm going to multiply it at the end. This is going to give me pretty big numbers, but I'm not afraid of that. So this gives me a new trinomial, x squared minus 30x plus 25 times 9 is 225. Okay? Now, this is a minus plus trinomial, so I know that when I factor a minus plus trinomial, I'm going to get an x, I'm going to get an x, and it factors into minus minus. Okay? And then I have to find two pairs of numbers that multiply to make 225, but at the same time they have to add or subtract to make 30, and lo and behold, it's 15 and 15. So I know this is a minus 15. I know this is a minus 15. I'm not done though, because I have to divide by 9, both of them. Okay? Because I have to balance it out, because I got rid of the 9 at the beginning. Now, does 9 divide into 15? Absolutely not. However, can you reduce it? You can. 9 over 15 reduces to 5 over 3. So both of these reduce to 5 over 3. So then remember, we're going to take the denominator number and we're going to move it to in front of the x. So I get 3x minus 5, and I get the same thing again, 3x minus 5. All right, now if you want to write this as 1 3x minus 5 to the second power, that is fine. All right.